Why should? Good evening and welcome to my classroom. Let us start with binomial theorem today. X plus a whole power n expansion is this. See, this expansion, the proof of this is by mathematical induction. You can skip that for the purpose. And this expansion has n plus 1 terms. This has n plus 1 terms. And NC0, NC1, NC2, and so on NCN are called the binomial coefficients. Are called the binomial coefficients. Are called the binomial coefficients. And the general term is the r plus 1th term. Tr plus 1 is equal to NCR x to the power of n minus r e to the power of r. This is the general term. And here n is a positive integer. N belongs to n is a positive integer. And middle terms. Middle terms. If n is even, n by if n is even, n by 2th term is the middle term. And if n is odd, then n plus 1 by 2th term and n plus 3 by 2th terms are the two middle terms. Are the two middle terms. All right. The numerically greatest term in the expansion of 1 plus x whole power n, numerically greatest term in the expansion of 1 plus x whole power n is obtained by finding out n plus 1 into mod x by mod x plus 1, and if this is an integer p, pth term and p plus 1th term are the numerically greatest terms, and if it is not an integer, then p, and if it is p plus some fraction f, then p plus 1th term is the numerically greatest. So this is about numerically greatest. And properties of binomial coefficients. If you consider 1 plus x whole power n expansion, we have nc0 plus nc1x plus nc2x square plus so on plus ncn x to the power of n. Now, if I put x is equal to 1 in this, I get 2 to the power of n is equal to nc0 plus nc1 plus nc2 plus so on plus ncn. So, which we write sigma ncr r ranging from 0 to n is equal to 2 to the power of n. So, sum of all the binomial coefficients is this. Now, suppose you put x equal to minus 1, you get 0 here, and we get nc0 minus nc1 plus nc2 minus nc3 and so on plus minus 1 to the power of n into ncn. Now, if I add this and this, if I say this as 1 and this as 2, and if I add these two, I get 2 into nc0 plus nc2 plus so on plus is equal to 2 power n. So, I get nc0 plus nc2 plus nc4 so on is equal to the power of n minus 1. Similarly, if I subtract, I get nc1 plus nc3 plus so on is also equal to 2 to the power of n minus 1. We get 2 to the power of n minus 1 if you subtract it, right. Next is, if you consider the expansion of 1 plus x whole power n, and if you this is nc0 plus nc1x plus nc2x square plus so on plus ncn x to the power of n. If you differentiate this with respect to x, differentiating with respect to x, we get n into 1 plus x whole power n minus 1 is equal to nc1 plus 2 into nc2 x plus etc. plus n into ncn x to the power of n minus 1. So, if I put x is equal to 1, I get n into 2 to the power of n minus 1 is equal to nc1 plus 2 into nc2 plus 3 into nc3 plus so on plus n into ncn. So, what we get here is sigma r into ncr, r ranging from 1 to n is equal to n into 2 to the power of n minus 1. Similarly, if I put x equal to minus 1, 0 here, and we get nc1 minus 2 into nc2 plus so on plus minus 1 to the power of n minus 1 ncn. So, which we can write sigma minus 1 to the power of r minus 1 ncr, r ranging from 1 to n is equal to r into ncr is equal to 0. This is what we get when we differentiate and put x equal to minus 1. Similarly, we can integrate and then put x equal to 1. We can also integrate 1 minus x whole power n and all that. So, these are the simple results that you can just remember. Now, having said this, we shall now move on to some problems. Now, you see here, the sum of the series, 1 into 10c1 by 2 power 9 minus 2 into 10c2 into 3 power 1 by 2 power 8 plus 3 into 10c3 into 3 square and so on minus 10 into 10c10 into 3 power 9. So this is the problem given. Now here, so we will write this as sigma r is equal to 1 to n we will write this as 1, 2, 3, etc. 10. So this is R. Then 10C R. R is equal to 1 to 10. And 3 power, you have 3 power 0, 3 power 1, etc. 3 power R minus 1 by 2 power R minus 1. So this is what is given. This is alternately plus and minus. So therefore, 2 power n, 2 power 9, 2 power this one, 10 minus R, and we have minus 3 whole power R minus 1. So this is what we are given. So this is sigma R is equal to 1 to 10. 1 by 2 power 10 can be brought out, R into 10 CR minus 3 whole to the power by 2 power minus R. So we can write this as instead of bringing this, we can as well keep this. This is R into 10 CR. We have 1 by 2 whole power 10 minus R minus 3 whole to the power of R minus 1. This is what we have. 1 by 2 whole power 10 minus R, and this is minus 3 whole to the power of R minus 1. So this we can write it as sigma R is equal to 1. One important thing is NCR can be written as n factorial by R factorial into n minus R factorial, right? So if I write n by R into n minus 1 factorial by R minus 1 factorial into n minus R factorial, this becomes n by R into n minus 1 CR minus 1. This result is one very useful result which we can use. So this is R into, so 10 CR can be written as 10 by R into 9 CR minus 1, like this we can write. And this is 1 by 2 whole to the power of 9 minus of R minus 1, which is 10 minus R. This is minus 3 whole to the power of R minus 1. Like this we can write. We can cancel R, and we can bring this 10 outside. 9 1 by 2 whole to the power of 9 minus half R minus 1 into minus 3 whole to the power of R minus 1. Now, if you consider this, this is nothing but 1 by 2 minus 3 whole to the power of 9. So, this is 1 by 2 minus 3 whole power 9 expansion. This part is 1 by 2 minus 3 whole power 9. So, this is 10 into 1 minus 6. So, minus 5 whole power 9 by 2 power 9 by 2 power 9. So, this is what it is. So, this is minus 10 into 5 power 9 by 2 power 9. 2 power 9. So, this is minus 2 into 5 power 10 by 2 power 9, which is minus 1 by 2 power 8 into 5 power 10. This is what we get, minus 1 by 2 power 8 into this much. So, minus 5 by 5 power 10 by 2 power 8, minus 5 power, problem here you put 2 power 8, and option C is correct. Repeat the whole thing once again. you just write like this. The only step that is to be considered is writing 10 CR as 10 by R into 9 CR minus 1, and the rest will fall in place. Next, the coefficient of extra power of n minus 5 in this expansion. So here n factorial into and we have x by 2 into NCR plus NCR minus 1 is n plus 1 CR. So x by minus NCR plus NCR minus 1 n repeated by NC2 and so on, x by n minus NCR plus NCR minus 1 n plus 1 CR by NC n minus 1. This is what we get. So here this one, like, so this is n factorial into, this is n factorial into x minus n plus 1 by 1, and here x by 2 minus, this is basically n plus 1 into n by 2 by n. So you get n plus 1 by 2 here into x by 3 into, you see here, here this is n plus 1 into n plus 2 into n plus 1 into n minus 1 by 1 2 3 by n into n minus 1 by 2. So this is n plus 1 by 3. So you can just observe the pattern here, x by n, we are getting here n plus 1 by 1, n plus 1 by 2 and n plus 1 by 3, and here we get n plus 1 by n. Verify this also, n plus 1 Cn is nothing but n plus 1, nc n minus 1 is nc1, which is n. So you get n plus 1 by n there. So this becomes so this is n factorial by, if I take 1 into 2 into 3 etc. n, so I get n factorial here plus 1 minus n plus 1 x minus n plus 1 repeated n times. This is repeated n times. So this is cancelled. In this, we want the coefficient of extra power of n minus 5. We want the coefficient of x power n minus 5. The general term TR plus 1 in this is NCR extra power of n minus r minus of n plus 1 whole to the power of r. So you want the coefficient of x power n minus 5, so put r is equal to 5. If I put r is equal to 5, the required coefficient will be minus of n plus 1 whole power 5. So that becomes minus NC 5 into n plus 1 whole power 5, which happens to be the option 1. Next, the sum 20C2 plus 2 into 20C3 plus so on, plus 19 into 20C20. So what we do here, let S is given that this is equal to S. S is equal to 20C2 plus 2 into 20C3 plus 3 into 20C4 plus so on plus 19 into 20C20. Now I will add 20C0 plus 20C1 plus 20C2 plus so on plus 20CN 20C20 on both sides. So that is, we have 20C0 plus 20C1 plus so on plus 20, 20. This we shall add on both sides. So left side will be s plus 2 power 20 and right side will be 20c0 plus 20c1. From 20c2 onwards, it is one more is added. So 2 into 20c2 plus 3 into 20c3 plus 4 into 20c4, 19 plus 1, 20 into 20c20. So this is what we get here. This is what we get. So this is what we get. So s plus 20, this much is equal to this much. So now we consider 1 plus x whole power n expansion. We consider 1 plus x whole power n expansion. Which is nc0 plus nc1x plus nc2x square plus 3x cube plus so on plus ncn extra power of n extra power of n. Now, if I differentiate this with respect to x, so if I do that, I get n into 1 plus x whole power n minus 1 is equal to nc1 plus 2 into nc2 into x plus 3 into nc3 x square plus so on plus n into ncn extra power of n minus 1. Now, in this, if I put x n is equal to 20, so I get 20 into 21 to the power of n minus 1. If I put x equal to 20, I get 20c1 plus 2 into 20c2 sorry, we are putting, we have put x is equal to 1 in this, putting x is equal to 1 in this, we are getting n into 2 to the power of n minus 1 is equal to nc1 plus 2 into nc2 plus 3 into nc3 and so on plus n into ncn. Now we put n is equal to 20. If you put n is equal to 20, we get 20 into 2 to the power of 19 is 20c1 plus 2 into 20c2 plus 3 into 20c3 so on plus 20 into 20c20. So while we want this, the value from here to here is this much, which is 20 into power. So our required thing is s plus 2 power 20 is 20c0 is 1 plus this value is 20 into 2 power 19. 20 into 2 power 19. So s is equal to, or s is equal to 1 plus 20 into 2 power 19 minus 2 power 20, which happens to be 1 plus 2 power 19, 20 minus 2, which is 1 plus 18 into 2 power 19, 18 into 2 power 19. So that is 18 can be 9 into 2. So we will write this as 2 power 20. So option C will come correct. So here in this problem, the takeaway is that we are adding 2 power 20 on both sides, which is 20c0 plus 20c1 plus 20c20, etc. 2 power 20. Now let us see the next one. The coefficient of extra power of 20, the expansion of 1 plus x square into x square plus 2 plus 1 by x square whole minus 5. So this is 1 plus x square whole power 40 into x power 4 plus 2 plus 2x square x power 4 plus 2x square plus 1 by x square whole power minus 5. This is what is given, which is 1 plus x square whole power 40 into x power 10 by x square plus 1 whole square whole power 5. So, this happens to be x power 10 into 1 plus x square whole power 40 minus 10, which is 30. Now, so, this is x power 10 into 1 plus x square whole power this much. So, in this we want of x to the power 20, because every term of this expansion is multiplied with x power 10. A term containing x to the power of 10 in this expansion when multiplied with x to the power of 10 will become x power 20. So, therefore, we will find out the coefficient of x to the power of 10 in this. So, coefficient of x to the power of 10 in 1 plus x square whole power 30. This is what we want. So, the general term of the TR plus 1 here, TR plus 1 is 30 CR x square whole to the power of 30 minus R. So, that means 30 CR is equal to x to the power of 60 minus 2R. This 60 minus 2R should be equal to 10. That means R is equal to 25. So, therefore, basically 35 or 30C5, any of that. So, 30C25 is the correct answer. Let us see the next one. The coefficient of x to the power of 50 in the expansion of 1 plus x whole power 41 into 1 minus x plus x square whole power 40. So, this is 1 plus x into 1 plus x into 1 minus x plus x square whole power 40. So, this is 1 plus x into this is 1 plus x. In this you want the coefficient of x to the power of 50. So, coefficient of x to the power of 50 in this case, see what happens here is x cube will deliver terms which are multiples of 3, and when it is multiplied with 1, it will be in the form of 3k, or when it is multiplied with x, they will be in the form of 3k plus 1. So, x 50 is neither in the form 3k or 3k plus 1. So, you do not get x power 50. A term containing x 50 basically you do not get from this. So, x power 50 is not possible. So, the required coefficient is 0. Option D is correct. I repeat once again, here 1 minus x cube whole power 40. So, it delivers terms like x cube, x power 6, x power 9, x power 12, etc. of the form 3p. And when those terms are multiplied with 1, they remain that way. And when those terms multiplied with x, they all become 3k plus 1 of the type x power 3k plus 1. So, either the terms that we get are of the form 3k or 3k plus 1, but 50 x power 50. So, your 50 is neither of those two. So, therefore, it is not possible to get the coefficient x to the power 50 from this. The number of terms in the expansion root 3 plus 5 to the power of 1 by 4 whole power 124, which are integers. So, let us write this 3 to the power of 1 by 2 plus 5 to the power of 1 by 4 whole to the power of 124. The general term of this is 124 CR 3 to the power of 1 by 2 whole to the power of 124 minus R into 5 power 1 by 4 whole power R. So, what we got is 124 CR 3 to the power of 124 minus R by 2 5 to the power of R by 4. If the term has to be integer, these two, the powers of these two should be integer. So, we should have R by 4 should be equal to P. So, R is equal to 4P. Now, what values P can take? P can take 0, 1, 2, 3, etc. 31. 31 4s are 124. So, P can take these values. Now, for these values, your 124 minus r by 2 is 124 minus 4p by 2, which is an integer 62 minus 2p, no issue. So therefore, there are 32 values for which this becomes an integer. 32 values, 0 to 31 are 32 values for which this will become an integer. So simple. Next. Sigma sigma I less than j lying between 0 to n. Ci Cj. This is called the sum of the products taken two at a time. The sum of the products taken two at a time. Suppose you have a1 plus a2 plus a3 whole square. So you have a1 square plus a2 square plus a3 square plus 2 into a1 a2 plus a1 a3 plus a2 a3. That a1 a2 plus a1 a3 plus a2 a3 is nothing but the sum of the products taken two at a time. Similarly, suppose you have a1 plus a2 plus a3 plus a4 whole square. So what you write is a1 square plus a2 square plus a3 square plus a4 square plus 2 into a1 a2 plus a1 a3 plus a1 a4 plus a2 a3 plus a2 a4 plus a3 a4. That is sum of the products taken two at a time. And here this notation sigma sigma, they are not two separate sigmas, as we must consider that as one symbol. So try to understand this very carefully. This is just a one symbol. It symbolizes what it talks about verbally. If you want to say that, it is the sum of the products taken two at a time. In ancient texts, they write the same thing as the sums taken 2 and 2 together. That is the sentence they write in English. The sums taken 2 and 2 together. That also can be said, but more clearly, it is sum of the products taken 2 at a time. If suppose you are taking sum of the products taken 3 at a time, you can write sigma 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 3 times you can write. And another point, when you write I less than j, see, for example, suppose you have a1 plus a2 plus so on plus an whole square. This is a1 square, a2 square plus so on plus an square plus 2 into sigma sigma ai aj I less than j, I ranging from 1 to n. I ranging from 1 to n. So now I want you to appreciate one point here. If you don't write this I less than j, if you don't write this, then you don't have to put this 2. If you don't write I less than j, this 2 need not be written. Why? Because I less than j enforces a particular order. When you take a1, a2, a1 should not be taken because I less than j. So therefore, when you take a1, a2 comes only once. So because we should have 2 in 2, so we are writing 2. But in case suppose you don't write I less than j, then a1, a2 comes once and a2, a1 also comes, and that will automatically become 2 into a1, a2 like that. So therefore, when you write I less than j, the 2 has to be written, and when you don't write I less than j, you need not write 2. So that's the point. So the same thing is applicable here also. Is a simple same. We are considering the binomial coefficients instead of a1, a2, a3. We consider c0, c1, c2. So just consider c0 plus c1 plus c2 plus so on plus cn whole square. This is c0 square plus c1 square plus c2 square plus so on plus c plus 2 into sigma sigma ci cj I less than j. So this is 2 power n whole square is equal to 2n. This is c0 square plus c1 square plus c2 square etc. cn square. It is 2n cn. How do we get it? Consider the expansion of 1 plus x whole power n. Also consider the expansion of 1 plus 1 by x whole power n. Multiply both and compare the coefficient term independent of x on both sides. So which is 2n cn. This value is 2n minus plus 2 into sigma So this is 2 into sigma sigma ci cj I less than j is equal to 2 power 2n minus. So if you simplify this, your result. So this is factorial 2 power 2n minus 2n is in terms of that we can just send this to the side and conclude that way. So we can sigma sigma ci cj I less than j is equal to, we can send this to the side, 2 power 2n by 2 is 2 power 2n minus 1 minus 1 by 2 into 2n cn. So option D match, option D will match. All right. So this is the problem, right? Next. Now let us go to the next one. The number of irrational terms in the expansion of 2 to the power of 1 by 5 plus 3 to the power of 1 by 10 whole power 55. The number of irrational terms. So let us first write the general term, which is 55 CR 2 to the power of 1 by 5 4 to the power of 55 minus R into 3 to the power of 1 by 10 4 to the power of R, which is 55 CR 2 to the power of 55 minus R by 5 3 to the power of R by 10. We will find the rational terms, and from the total number of terms, if you subtract the rational terms, we get the irrational terms. So for that, R by 10 is an integer. For it to be rational, let us say P, so R is equal to 10P. And here P takes values 0, 1, 2, 3, 4, 5. So when P is equal to 5, we get R is equal to 50, and that's the maximum. So it can't exceed 55, right? So now 55 minus R by 5 is 55 minus R is 10P by 5, which happens to be 11 minus 2P. 11 minus 2P. Now, for 11 minus 2P, for P is equal to 0, okay, for P is equal to 1, for P is equal to 2, like that, P is equal. So you have 6 values which are possible totally. So the rational terms are only these 6 values. So out of 56 terms which are there, 6 terms are rational, the remaining 50 are irrational. So the answer is 50. So let us move on to the next problem. The first integral term in the expansion of root 3 plus cube root of 2 whole power 9. So this is, we'll write this as 3 to the power of 1 by 2 plus 2 to the power of 1 by 3 whole power 9. Again the same thing, TR plus 1 is equal to 9CR 3 to the power of 1 by 2 whole power 9 minus R 2 to the power of 1 by 3 whole to the power of R. So this is 9CR 3 to the power of 9 minus R by 2 2 to the power of R by 3. 2 to the power of R by 3. So therefore, now R by 3, if it has to be integer, R by 3 is equal to P, so R is equal to 3P. For this, here P takes values, P is equal to 0, P is equal to 1, P is equal to 2, P is equal to 3. So R is equal to 9 maximum. So 9 minus R by 2 is 9 minus 3P by 2. Now when P is equal to 0, we get 9 by 2 is not an integer, and for P is equal to 2, for P is equal to 1, for P is equal to 1, I get, sorry, 9 minus 3 by 2, which is 6 by 2, which is 3, which is an integer. So, first integral term will be for p is equal to 1, for which r is equal to 3p, or r is equal to 3. So, that means the fourth term, r is equal to 3 means the fourth term. So, option C comes correct. All right. If an is equal to this much, if an is equal to sigma r is equal to 0 to n 1 by NCR, 1 by NCR, sigma r is equal to 0 to n r by NCR. All right. So, let S is equal to sigma r is equal to 0 to n r by NCR. Now, notice this, if I replace r with n minus r, the summation won't change. The same summation comes in the reverse order. So, therefore, you can as well replace r with n minus r. So, replacing r with n minus r, so we get S is equal to sigma r is equal to 0 to n minus r by NC n minus r. NC n minus r is again NCR only. I get 2s is equal to sigma r is equal to 0 to n, r plus n minus r is n by NCR. So, 2s is equal to n into sigma r is equal to 0 to n 1 by NCR. So, s is equal to n by 2 into this value is what? This value is an. So, this value is an. So, n by 2 into an is what you get? 2 into an. So, option C comes correct. Right. This is a simple problem. You can practice few more problems on this variety. Next. The coefficient of x to the power of 53, in the expansion of sigma k is equal to 0 to 100 ck x minus 3 whole to the power of 100 minus k into 2 to the power of k. Basically, this is nothing but the expansion of x minus 3 plus 2 whole to the power of 100. This is this entire sigma thing. This is the, you see this is the k plus 1th term, the general term. So, this is x minus 1 whole power 100. We can as well write this as 1 minus x whole power 100. Now, coefficient of x to the power of 53. So, the coefficient of x to the power of 53 in this is minus 1 to the power of minus 1 to the power of 53 NC 100 C 53. So, that becomes minus 100 C 53, minus 100 C 53. So, that becomes option A. So, that is it. The moment we recognize that this whatever that is given is nothing but the expansion of 1 minus 3 plus 2 whole power 100 expansion, the problem gets over. All right. Now, here the sum of this series. Now, this is S is equal to this series. Assume that there is 3 power 0 here. So, S is equal to, if I take 3 power minus 1 common here, I get 10C, 10 is after all 10C 0, minus 3 into 10C 1 plus 3 square into 10C 2 minus 3 cube into 10C 3 plus so on, plus 3 power 10 into 10C 10. 3 power 10 into 10C 10. So this whole thing is nothing but the, you see here, 10C0 minus 10C1 into 3 plus 10C2 into 3 square and so on. Therefore, it has to be the expansion of 1 minus 3 whole power 10. So that means it has to be 2 minus 2 whole power 10. So it is nothing but the option D, just a one step problem. All right. Here this root is only up till here. So this is root 3 plus 1 whole power 2n minus root 3 minus 1 whole power 2n. All right. So this is root 3 plus 1 whole power 2n. Expand, it is just a simple addition, root 3 whole power 2n plus 2n c1 into root 3 whole power 2n minus 1 plus 2n c2 into root 3 whole power 2n minus 2 and so on. Expansion of root 3 minus 1 whole power 2n is root 3 whole power 2n minus 2n c1 into root 3 whole power 2n plus 2n c2 root 3 whole power 2n minus 2 minus 1. If I subtract, we get root 3 plus 1 whole power 2n minus root 3 minus 1 whole power 2n is equal to this much. So this is what you get, and therefore this powers are getting cancelled, becoming an irrational number. So it's an irrational number. So this is an irrational number. Next. The coefficient of x to the power of 50 in this expansion. All right. So let S is equal to 1 plus x whole power 1000 plus 2x into 1 plus x whole power 999 plus 3x square into 1 plus x whole power 998 plus so on plus 1001 x power 1000. Now, if this is a arithmetico-geometric progression. So the common ratio of the GP part is x by 1 plus x. So x by, we will just multiply this with x by 1 plus x and then multiply that with s. So that we get x into 1 plus x whole power 999 as 2 for AGP. It's AGP in fact. So this is plus 2x square into 1 plus x whole power 998 and so on. And here I get 1001 x power 1001 by 1 plus x by 1 plus x. So if I subtract this, we get s into 1 minus x by 1 plus x is equal to 1 plus x whole power 1000 plus x into 1 plus x whole power 999 plus so on. And here if you, because you are subtracting, this is 1 plus x. All right. So this is is equal to, and this is from here to here. Okay. From x power 0 to x power 1000, these are 1001 terms. These are 1001 terms. Okay. And these 1001 terms, they form a GP with a common ratio x by 1 plus x. I'm not sure whether the space will be sufficient. Let us try. So, this is a into x by 1 plus x is the common ratio. So, 1 minus x by 1 plus x whole power 1001 terms by 1 minus x by 1 plus x. This is s by 1 plus x is what we get here. Minus x to the power of 1001 when I multiply with this, this is 1 plus x this much into 1 plus x whole power 1001 minus x to the power of 1001 by 1 plus x whole power 1001 divided by 1 plus x minus x. So, 1 by 1 plus x. So, this will go minus 1001 x to the power of 1001, and here is the problem, the space issue. All right. So, this is s is, if I send this 1 plus x this side, I get s is equal to 1 plus x whole power 1002 minus x power 1001 into 1 plus x, x power 1001 1 plus x minus 1001 into x power 1001. So, you want the coefficient x to the power of 50 in this, and this does not deliver that, this also does not deliver that. If you want the coefficient x to the power of 50, you should look at this only, which is 1002 C50. This is the coefficient of x to the power of 50, 1002 C50. So, option C comes correct. Okay. Then sigma r is equal to 1 to n, sigma p is equal to 1 to n r minus 1, NCR RCP 2 to the power of p, this value. Now, this NCR is anyway is not affected by this sigma, because this sigma ranges from p to r minus 1. We will bring this NCR out of the sigma. So, sigma r is equal to 1 to n, NCR into sigma RCP into 2 power p, p ranging from 1 to r minus 1. So, basically what is this? This is sigma r is equal to 1 to n, NCR into, this is nothing but RC1 into 2 plus RC2 into 2 square plus 1 plus RCR minus 1 2 to the power of r minus 1. So, this is sigma r is equal to NCR into, I will just add RC0 plus RC1 into 2 plus RC2 into 2 square plus 1 plus RC minus 1 2 to the power of r minus 1. I will also add RCR into 2 to the power of r. So, basically I have added RC0, that means I have added 1. So, I will subtract 1. Added RCR in 2 power r. So, I will subtract 2 power r. So, this much I will subtract. So, that this becomes sigma r is equal to 1 to n, NCR into 1 plus 2 whole to the power of r minus 1 minus 2 to the power of r. So, this is sigma r is equal to NC minus 2 power r, which amounts to sigma r is equal to 1 to n, NCR into 3 power r minus sigma NCR minus sigma r is equal to 1 to n NCR into 2 power r. So this is, the first one is NC1 into 3 plus NC2 into 3 square plus so on plus NCN into 3 power n. And then the second one is NC1 plus NC2 plus so on plus NCN. And then the third one is nothing but NC1 2 plus NC2 into 2 square and so on plus NCN into 2 power n. Each branch has a deficit. So if I add plus 1 here, I must subtract 1, and if I add 1, this becomes 1 plus 3 whole power n expansion and minus 1, because NC0 we are adding. This is the first one, minus, this is nothing but 2 power n minus 1, because NC0 is missing. And this is also same thing. If I add NC0, it will become 1 plus 2 whole power n minus 1, because we are adding, so we are subtracting. So we get 4 power n minus 1 minus 2 power n plus 1 minus 3 power n plus 1. So basically what we are getting is 4 power n minus 2 power, okay, this 4 power n, if you want, you can write it as 2 power 2n minus 2 power n minus 3 power n plus 1, which is 2 power n minus 3 power n plus 1. 2 power n minus 3 power n, 2 power, sorry, here one mistake. So this y 4 power n, sorry, this is 4 power n minus 3 power n minus 2 power n. So this is 2 power 2n minus 3 power 4 power n minus 3 power n minus 2 power n, 4 power n minus 3 power n minus 2 power n plus 1. Okay. So this is what we get, plus 1 minus 2 power n you add. So option A comes. Okay. The coefficient of extra power of 99 in this expansion. So this expansion is x plus 1, x plus 2, x plus 3 and so on, x plus 100. So if you want the coefficient, this is a polynomial of degree 100, and if you want the coefficient extra power of 99, every time you assume that you have closed one bracket and the leading term will be x power 99, and that x power 99 when multiplied with the constant term you get, so you get one term. So if I assume you have closed x plus 1, the remaining terms factors, if you multiply, it is a polynomial of degree 99. That x power 99 when multiplied with 1, you get the coefficient x power 99. Similarly, if you close x plus 2 and then do the same thing, you get 2, 3, 4, etc. 100. So this is the coefficient x to the power 99. So this is 100 into 101 by 2. So this becomes 5050. So option A. Okay, the value of sigma r is equal to 0 to n NCR by r plus 2. So this is nothing but NC0 by 2 plus NC1 by 3 plus NC2 by 3 square 4 plus so on plus NCN by n plus 2. So if I consider the expansion of, whenever this by something is there, usually it will be on integration. If you consider the expansion of 1 plus x whole power n, which is NC0 plus NC1x plus NC2 x square plus n extra power of n. Now I will multiply throughout with x. So x into 1 plus x whole power n is NC0 x plus NC1 x square plus NC2 x cube so on plus NCN extra power of n plus 1. If I integrate this under the limit 0 and 1, I get NC0 into integral of x is x square by 2 from 0 to 1 and C1 into x cube plus NC2 x power 4 by 4 from 0 to 1 plus so on plus NCN x power n plus 2 by n plus 2 from 0 to 1. So, this is NC0 by NC0 by 2 plus NC1 by 3 plus NC2 by 4 and so on, plus 1 plus NCN by n plus 2. Now, here if I put x is equal to t, if I put 1 plus x is equal to t, I get dx is equal to dt. Also, when x is equal to 0, I have t is equal to 1 lower limit, and when x is equal to 1, t is equal to 2 upper limit. So, I get integral of 1 to 2, x is t minus 1, t to the power of n, dx is dt. So, this is integral 1 to 2, t to the power of n plus 1 dt minus 1 to 2 t to the power of n dt. So, this is now t to the power of n plus 2 by n plus 2 from 0 to 1 minus t to the power of n plus 1 by n plus 1 from 0 to 1. So, this becomes 1 by n plus 2 minus 1 by n plus 1, which is n plus 1 minus n minus 2 by n plus 1 into n plus 2, which is minus 1 by n plus 1 into n plus 2. So, yeah, one of these. No, it is the limits are from 1 to 2. Okay, the limits are from 1 to 2. I have applied from 0 to 1 here. 1 second. The limits are from 1 to 2, right? So, when you apply these limits, the change limits are from 1 to 2, right? So, 1 to 2. So, if you apply these limits, you get 2 to the power of n plus 2 by n plus 2 minus 1 by n plus 2 minus 2 to the power of n plus 1 by n plus 1 minus 1 by n plus 1. So, we need to do a little, we have here. So, the option B is correct. Yes. Now, this is sigma r m is equal to r is equal to 0 to m ten C r into 20 C m minus r. So, that means what we are having is 10 C 0 into 20 C m plus 10 C 1 into 20 C m minus 1, so on. Plus so on, plus 10 C m 20 C 0. So, basically the sum of these two numbers is always, in that case, just consider the expansion of 1 plus x whole power 10, which is plus 10 C1x plus 10 C2x square plus so on plus 10 Cm extra power of 10 minus m power of m, sorry, 10 Cm extra power of m and so on. You also consider the expansion of, we have to multiply that with that. So, you also consider the expansion of 1 plus x whole power 20, which is 20 C0 plus 20 C1x plus 20 C2x square plus so on plus 20 x plus 1. So when you multiply these two and consider the coefficient extra on both sides, so then this into this we get 20 extra power of m, this into this we get extra power of m, like that. So multiplying these two and comparing the coefficient of extra power of m on both sides, coefficient of extra power of m, if you consider x whole power 20, we get this side the coefficient of extra power of 20 m is 10c0 into 20cm plus 10c1 into 20cm minus 1 and so on. So this is 1 plus x whole power 30 basically, and coefficient of extra power of m in this is 30 cr. Now 30 cr is maximum because r is even number. 30 cr is maximum when r is equal to, so r is equal to 15, it's maximum. Okay, right. The next one, p is equal to 6 root 6 plus root 14 whole power 2n plus 1. So let us consider 6 root, this is 6 root 6 minus 14 into 6 root 6, just wait. This is 36 into 6, maybe 216 minus 196 by 6 root 6 plus 14. All right. So this is 20 divided by 6 root 6 plus 14. So you can see 6 plus 14 is 20. So the denominator is greater than the numerator. Therefore, this is a proper fraction. So therefore, 6 from this we can conclude that 6 root 6 minus 14 lies between 0 and 1. So if something lies between 0 and 1, any integer power rise to positive integer power rise to it also will lie between 0 to 1. So I'll write this to the power 2n plus 1 throughout. So this is 6 root 6 minus 14 whole power 2n plus 1 less than 1. So let me call this as capital F. Now consider 6 root 6 minus 14 whole 1 expansion, which is 2n plus 1 C0, 6 root 6 whole power 2n plus 1 plus 2n plus 1 1 14 and so on. You also consider the expansion of 6 root 6 minus 14 whole power 2n plus 1. This is 2n plus 1 C0, 6 root 6 whole power 2n plus 1 minus 2n plus 1 C1 into 6 root 6 whole power 2n into 14 and so on. Now we'll subtract one from the other. So if I do that, 6 root 6 plus 14 whole power 2n plus 1 minus 6 root 6 minus 14 whole power 2n plus 1. If I do this, if I subtract this, root 6 having odd powers will get cancelled. So these terms will get cancelled. So you get 2 into 2n plus 1 C1, 6. So this is an integer, right? Now this is capital R minus this is capital F is an integer. So now capital R is basically its integer part plus its fractional part minus capital F is an integer. So fractional part minus capital F is integer minus integer is an integer. Now you see small f lies between 0 and 1 and capital F also lies between 0 and 1. So therefore f minus f has to be 0 because lie between 0 and 1. This implies that the small f is equal to capital F. So therefore you want R or P. So this is, we called it as P. We instead of R we call, so this is P basically. So this is P. All right. So therefore, Pf is nothing but P into capital F. So P is what? 6 root 6 minus 14, 6 root 6 plus 14 whole power 2n plus 1, and capital F is 6 root 6 minus 14 whole power 2n plus 1. So when you multiply, you get 216 minus 90, 196, which is 20 to the power of 2n plus 1. So 20 to the power of 2n plus 1. So P of is equal to 20 to the power of 2n plus 1, which is your required value. Okay. All right. We have done some of these varieties. Do good practice, and we shall meet in another session. Thank you.